Hello everyone, and today we're going to talk about oscilloscope probes because I will be building a new one. So let's first explain a little bit why I would want to build a new one. Because I already have 4 of these. These came with my oscilloscope, and these are pretty much, if you've ever worked with an oscilloscope, you probably used one of these. And these probes are fine for, general oscilloscope applications, but the thing that I'm using the scope for is kind of outside of that, because I want very, very accurate readings that are a lot more accurate than what you would maybe usually do, like measure PWM signal, maybe measure some AC circuits or stuff like that. These probes are not really that great for them because these are like the standard 1x, 10x switchable probes, and really you're supposed to use these in 10x mode, because if you switch these to 1x mode they have basically no bandwidth, and they also have some there's some inaccuracy issues. And then also there's the part where like you rely on this ground clip for your grounding, which is, a very long clip that splits far away from the actual contact point. And this picks up a ton of interference. Really, really bad. So, like you can remove this and then have like a little ground clip around here, which does kind of get rid of that problem, but it's still the coax for this probe is still not great. And you're still very much supposed to use it in 10x mode, which, we don't always want to. So that's why I'm gonna be building one of my own probes using this. So what this is basically already the probe assembled, except that the actual hookup part is non-existent yet, which is what we're gonna be building in this video. But it's essentially 3 parts. So first it's just a BNC Y splitter. Then we have a 50 ohm termination resistor. And then just a coax wire or cable or whatever. Now this used to have another end with a BNC connector on it. I've already built one of these probes. This is why, it's cut here. But basically it was a female to female coax cable that I just cut in the middle. This goes onto the other connector here. And this is what's basically a lot more accurate for what I do than the included probe 1x probe. Because this does not have any, it has a termination resistor, but it doesn't have any resistor on like the actual sense line where it divides by 10, which is what a 10x probe does. So this is going to be a 1x probe. And specifically, this 1x probe is gonna be a lot more accurate and also have more bandwidth and just generally be better than the included probe in 1x mode. Now, and this is really basically anything you need. You do want to have this 50 ohm termination resistor because this coax wire is literally just a coax wire. It does not have any termination built into it. A normal probe that you buy does. And if you use this without a termination resistor, you can have lots of issues like signal reflection, those just picking up more interference. You do want this termination resistor. But anyway, so the kind of probe that we're going to be building is also going to have an advantage in how it hooks up, which I can show on this 480 because it has both styles of hookups. Now this is gonna be the new style of hookup that I'm gonna build. This is basically a little, pin connector that we're gonna be plugging into, and it's just, with a few short wires just connected to a resistor, capacitor behind the core. And this right here is what I used before, which is basically just 2 capacitor legs that the clip would, clip onto. And this is not great. Mostly this is a fire hazard, because if those 2 clips ever touch, that will short out the VRM and potentially cause a fire. And also this sticks up, so if I rest the card down like this, pretty high chance I'm gonna break this off, whereas this cable's just gonna get squished and be fine. And yeah, so this is a more proper hookup method, especially because like you're just plugging into the holes of this one, whereas the clip can always, like, if you pull on it a little bit, it probably usually falls off. And also, if you just change how this is hooked up a little bit, that can drastically change your measurements. Like, I had huge issues with the included probes that the oscilloscope was reading very, very high on voltage. Like, with my multimeter and my EVC, I would read something like 1.2 volts at the VRM output, and then the oscilloscope would claim that I'm running 1.25 volts directly behind the core, which is not how power planes work. And this was a pretty consistent thing across cards until I used the other probe that I had already made of this style, which now reads pretty much exactly the same voltage level that the multimeter does. Now, part of that was probably also the hookup method and stuff like that, but the probe being more accurate is of course also a factor in that. But yeah, so we are gonna build our little 1x probe right here, which is, it's really good value. Like, you could spend a lot of money on like an active probe or a high-end passive probe. They're gonna be very expensive. This right here, these two probes that I'm gonna build myself, they cost me around 60 euros, and half of that was basically shipping from DigiKey, because DigiKey ships from the US, and they are fairly expensive compared to other, part websites. But I wanted like these specific parts because I don't know that much about like building proper probes, so I was just recommended these parts, and only DigiKey had them. So I just bought them off DigiKey, and I just paid a lot of shipping. But yeah, so like still 60 euros for like two very accurate probes. That's a pretty good value. Like, you can spend hundreds of euros on high-end oscilloscope probes, and when it comes to accuracy, these ones still have a bit of noise, but it is so little noise, like you can't see it if you look for it, but it is so little noise that it's not gonna affect what I'm measuring with these. So for my purposes, these are perfectly fine. Unlike the other one, which like read the voltage high and had huge issues with catching interference. Like, if you just change the angle of the clip slightly, sometimes you would like see twice the VPP. It is really bad. But yeah, so let's get right into it. So this is a coax wire, which means it has two conductors in it. It has a core conductor, which is the actual signal carrying component, and then it has a ground shield in sort of a circular pattern around it, which makes soldering a bit more interesting here, because we don't just like have two wire cores that we can just, tear apart. We have the signal in the middle and then a ground shield around it. So I'm gonna try to remove the insulation so that I can show you what I mean. It doesn't want to come off. Oh, I just cut the... It cut the entire thing. Yeah, this is not so good. There we go. So, you can see the ground shield. And if we now kind of like bend those away, you will see the sort of like rubber or more like plastic insulator that's around the core wire. So this right here, all of this is the ground shield, and then here in the middle of this sort of like kind of see-through plastic thing, that's the actual signal conductor. So we're gonna have to carefully remove the insulation from that too. Actually, before we do that, I already wanna like put a bit of solder into this ground shield, so that it just kind of stays where it is. So I'm gonna need some flux. And let's just tin this, put a bunch of solder into this. Damn, it's sucking up quite a lot. Yeah, I just want all the ground shields to be like soldered together. It's gonna make it a bit easier later. I can add a bit more. Okay, that should be good enough for now. Yeah. And it did actually kind of melt a little bit of the rubber insulator. So we have a little bit of the signal core wire sticking out already. I don't know if that's gonna be enough to solder onto. Probably not. So I'm gonna carefully try to remove a bit more of it. Sadly, this insulation material is very soft and it just kind of tears. It's a little bit like hot glue. And we really don't want to damage the signal core. Yeah, I got some of it off, but it just like stretched whatever was left out. Can we just carefully... Oh, it looks like we might be able to just carefully pull it off. Oh no, there's one of the strands of the signal conductor in there. Okay, so I got it mostly free. Away. Okay. Yeah, I can cut that off later. What's left on the side, let's just put some flux on this as well. Pre-tin that. And then... So that shouldn't need much tin. That's yep. Okay, so that is now the ground shield and the signal conductor pre-tinned and sort of put away from each other. And now we want to put something on here that can actually connect into these terminals here. And for that, I found out that pretty much just what I have and is convenient to use is just cut off capacitor legs. So these are just, like many capacitors when you buy them, they come with super long legs. And I always cut those off before I install them. And I just have a bunch of these left over. And we can just cut one to size. We want to have it as short as possible. And these are basically perfect thickness that they fit into the terminal and also stay in it, and not just like come back out if you pull on it slightly. And yeah, so yeah, let's try to estimate. Like the signal core wire is already basically perfect length. Do we even need? We might wanna. Because the signal core part already kind of looks like it might already fit into a terminal. It does, but it's not really sticking that well, so I might want to put something on there. Yeah. So let me estimate how much of it is gonna be in the terminal and how much is gonna be left to solder onto. It's about that much is gonna be in the terminal. So I'm gonna like double that size roughly, and then cut it off. And yeah, we're gonna use a slightly longer one for the ground, because it's gonna have to fit in there, into that like big blob of ground shield. But let's do the signal conductor first. So I'm gonna act my holder thing. Put that in. Ah, good. All right. Put a little bit of flux on it as well. And now very carefully try to connect it. Okay, so that is on there. And now for the ground side, basically. Like now this should be able to stick in just fine. So if you put that in. Yep. That fits pretty much perfectly, also pretty much perfect length. And now we just need to do the ground one, so we need to cut a little bit of it as well. So like how much roughly? Like this about. Okay, same idea. Let's climb that into here, and I dropped it again. Come on. More flux. And I'm gonna clean the tip. Okay, this is gonna have to be a bit careful. That is very far apart and not sized correctly. That is not a good connection. It's more like it. But I think my ground blob just split apart. Yeah, it kind of split apart. We don't want that. Like you see those two things that go like out on the side. Also the length is mismatched. This has the potential to become slightly annoying. Also, I might have to redo the entire thing because the plastic part around the signal conductor is melting when I use the soldering iron on it, and it looks like it might have shorted out against it already. So that is not good. Actually, it still looks good, but like it could change very quickly if I do this more. How do I do this? Like, I can't use the probe like this with the length mismatched. I need to pull this thing out further. No, don't short. Still mismatched. That is still mismatched. Yeah. Like, is it shorted? It looks really bad. The other probe I did was a lot easier to do. Like, do we have a short? No. Okay. Just seeing the 50 ohm resistor. So it's not shorted out yet, but the insulation layer is melting away every time I put the iron on it, and it's still length mismatched. And I can't really make the signal thing any shorter because it will not fit into the terminal anymore. That's bad. I need to pull this out. Can I like try it like this and then just very carefully pull it out? And suddenly my soldering iron no longer melts solder. Because all the heat's just going into the holder thing. Great. So I can't do it like this. This is not great. I might redo this probe. Like, it does fit into it, it just doesn't go to the end on the ground side. It's probably fine. It's just, if I keep messing with this more, it's just gonna melt through the insulation. It's no longer gonna, like, work. So I'm considering to just, like, call it done here. Not a great example for the video, but it's just how I make them. So, like, it's still not shorted, right? No, reading 50 ohms, just as it should. Yeah, I mean, this is not perfect. I would also, like, you would also want to put, like, shrink wrap on this. I do not have any shrink wrap, so I'm just gonna have it exposed like this. Which is also gonna make it slightly worse. Like, you do want to insulate these. Like, if it's just exposed like that, it picks up interference easier. But yeah, I think I'm just gonna call it quits here. Like, it's probably fine. I'm gonna test it quickly, to make sure it's not, like, super bad. Yeah, not my greatest work, but I think the probe will be fine. It just looks really bad, like how it's length mismatched and how the insulation's, like, basically non-existent at this point. Not great. Actually, yeah, no, I'm just gonna cut the excess off. Damn, it doesn't want to cut shorter. There we go, now it's matched. Now it won't go to the end of the terminal now, but it will still go in. No, come on. There you go. Like, it will still go in, and it's like, it stays. It's not the greatest ever. These are kind of fiddly to make. The other one went better, but I didn't record that one. Anyway, so I'm gonna hook this up to the oscilloscope real quick to test it, if it, like, you know, is mostly fine, if I can use this probe to get good data. It's probably, like, I can probably guarantee it's better than this probe. Because this thing's awful. Like, this is really bad. So, yeah, let's hook it up to the oscilloscope real quick and measure something and see if we can, like, see any major interference issues. So, be right back. Alright, here we are. I have my new probe on channel 1, the old one's on channel 2, and I'm looking at GPU-Z transients right now on an HD 5770. Don't be confused with the heatsink, I stole that off a 7770. But yeah, so if we go look at this, we have the probe connected right here to, you know, a terminal just like that one, and here's the other one I made, which, as you can see, has a lot longer connections. That is why I wanted to make this one as short as possible, because that you can also pick up some extra interference if your connections are just longer than they have to be. And it seems to be mostly fine. Now, if I capture a single transient right here and zoom in on it, that is very smooth. You can see some slight interference, like those little peaks right there, where it goes a bit up and down. That's the interference it still picks up, but as you can see in the grand scheme of things, it is so small. Like, I have to physically zoom in on the screen where you can, like, see the dust on it to really see it. That is not an issue. Look how smooth this is. And this is without the bandwidth limit. I do not have the bandwidth limit on. On the old probe, it was running in 10x mode and had the bandwidth limit on, because if without the bandwidth limit, the old probe was just reading like 400 millivolts peak to peak, and even if I zoom all the way out to like 50 milliseconds, we're reading 140 millivolts peak to peak now. So yeah, the old probe was reading a lot of interference compared to this one. And this is also, like, comparing to what I've seen from other people, like in Bullzoid's oscilloscope videos, also from Exaberries. I forgot to say that earlier. He's the person that recommended these exact things to me, because he made his own probes just like this, just a bit more properly than I did. And this lines up with all the numbers I've seen. This is what it should look like. And yeah, like, if you zoom in, there is not really any interference. It is really smooth. Like, you can occasionally see some slight interference where there's just these like really small, like, spiky oscillations, but this is not gonna affect anything. This is so little. Like, this is maybe like 10 millivolts of swing, and yeah, I don't think this is gonna change anything in the grand scheme of things. So yeah, probe works pretty well. So even with my super bad soldering and without any shrink wrap around it, it does still work. And if I put shrink wrap around this and made the probe a bit more properly, then this, what's left of interference, would probably also be less significant. But I'm already pretty impressed with how this performs, because this is nowhere near what the old probe did. The old probe was so noisy, and it needed the bandwidth limit on. Like, this one also drops a bit of noise. Like, if I turn the bandwidth limit on, you can see we lose, it occasionally goes down to 130 millivolts peak to peak. If I turn it off, it more about stays at 100, and actually also still goes down 130 well, like, okay, we saw 150 real quick. So like a 10 millivolt peak-to-peak difference with the bandwidth limit on, which, considering that this probe, as far as I understand, should have a lot more bandwidth than a regular probe in 1x mode, you do want to have this off, actually, because if we turn the limit on, we might be actually filtering out not something that's noise, but actually, you know, transients that occur, because, yeah. But anyway, so probe works. I'm not really that proud of how it went, but in the end I got a working probe out of it, and yeah, this is just what I'm gonna use going forward. This is so much more accurate than the included probes, and yeah, so I hope this video was somewhat interesting, and until next time, goodbye.